to our MOOC aLIFEca, Introduction to Sustainability and LCA. During this part of the lesson, we will discuss life cycle assessment and in particular the system boundaries. So let's start. What are system boundaries? So the system boundary basically defines which process will be included in or eventually excluded from the system, and it delimits which processes should be included in the analysis of a product system, including, for example, whether the system produces any co-products that must be accounted for by system expansion or allocation. Defining system boundaries is partly based on a subjective choice made during the scope phase, when the boundaries are initially set. So, into an LCA process, we have to consider the following boundaries. First, boundaries between the technological system and nature. They begin at the extraction point, so for example raw materials and energy, and the final stage is the waste generation. Then we have the geographical area, so the boundaries related to the geography of a process. Then we have the time horizon, so in this case boundaries are set in time, and the LCAs are carried out to evaluate present impacts and predict some future scenarios. And then we have boundaries between the current LCA and related LCAs. This is useful when activities are interrelated and must be isolated from each other. When still talking about system boundaries, we have to say that there are four main options to define the boundaries used into an LCA. These are cradle to grave, cradle to gate, cradle to cradle, and gate to gate, and also well to wheel, which is specific for automotive. But let's start with the very first one, which is cradle to grave. As you can see here in this figure, this boundary includes the material and energy production chain and all processes from the raw material extraction through the production, also the transportation and use phase, up to the product's end-of-life treatment. We can say that the cradle to grave is the conventional disposable approach. This is no longer sustainable because a large part of greenhouse gas emissions are due to precisely to this production approach, which is based basically on fossil fuels. When we talk about indeed cradle to gate, this boundary includes all processes from the raw material extraction through the production phase, and it is used to determine the environmental impact of the production of a product. So it excludes the phase of use and disposal of the same. Then we move to the third one, which is cradle to cradle. This approach is an essential tool of the circular economy because it allows to transform production processes by reducing waste to a minimum level and allows to create a positive footprint. It can be the process boundary through three fundamental elements. First, everything is a resource for something else. Second, use clean and renewable energy. And third, celebrate diversity. Then we move to gate to gate. This boundary includes the processes from the production phase only. And usually it is used when we want to determine the environmental impact of a single production step or process. So we have seen that there are quite a different number of boundaries, and the last one is the well to wheel. As I said, this is a specific system boundary that is used to assess the total energy consumption or the energy conversion efficiency and emission impact of, for example, motor vehicles, marine vessels, aircraft, etc. And it includes the carbon footprint and the fuels that are used in each of these transport modes. The well-to-wheel method is good and useful to evaluate the impacts of fuel using a well-to-wheel evaluation, while a traditional cradle-to-grave approach. Let's move now to the LCA phases, which have been introduced previously but only mentioned. So, LCA phases. We all know that an LCA study must be structured according to 3 consequential phases. The fourth one is actually a phase that is always active, and as you can see here in the figure, is called the interpretation phase. The first phase is the goal and scope. The second is the life cycle inventory. The third is the life cycle impact assessment, and the fourth, as I mentioned, the interpretation phase. So let's start with the first one, which is the goal and scope. Definition of goal and scope is something that is fundamental, because during this phase you can design the framework of the study. The goal and scope identifies which is the reason why it is performed, and it describes all its characteristics. You have to define, it is mandatory actually to define which is the objective of the study, which is the functional unit, what are the system boundaries that we have analyzed before, what are the categories of data, and what is the data quality. Then we move to the goal and scope, which is the objective of the study, which is basically what we explored before. The objective of the study refers to the applications for which it is intended and the reason for carrying out an LCA. The different approach is based on, for example, comparing products and services with each other, comparing the object of the study with a reference standard, planning improvements for an existing product or service, or designing a new product and service. The second one is the functional unit, always part of the goal and scope. What's the functional unit? The functional unit is essentially indicates the reference object of the LCA study, to which all input and output data will be normalized, and it is a necessary reference to allow the comparability of LCA results. The third one is the system boundaries. We have already mentioned that these are necessary to define which process will be included in or excluded from the system, and it delimits which processes should be included in the analysis. Then we have the categories of data. Basically, they determine the possibility of collecting information in the field, measuring, calculating, estimating them, and obtaining them from existing databases. Here it is possible to sort collected data by 3 essential categories: the primary data, the secondary data, and the tertiary data. Then we have the data quality. This requirement is necessary in order to have consistency in terms of both geographical, temporal, but also technological coverage, as well as a correct representation and a reliable source. So, the second phase of our LCA is the life cycle inventory. The inventory analysis is, we can say, the most delicate and demanding phase of an LCA study, because here the input and the output in the life cycle of the system are defined and quantified through a model that represents it in the most reliable possible way. The most representative scheme can be divided into 7 sequences. When the process has been outlined, it is possible to proceed with the effective data collection activities, and all the data must be categorized and filed in an inventory table, which is a fundamental basis for the next phase of impact assessment. So, when coming to the life cycle inventory, the main production, which is one of the 7 steps, this sequence highlights the product's priority manufacturing process. In this phase, you can see that the main process steps are highlighted and the major material flows. Second, which is called secondary production. This sequence relates to the manufacturing process of the product, which is carried out during production of the main product. Then we have the production of auxiliary materials. This phase aims at extending the process during and after manufacture of the product. And this phase will allow to analyze the extraction, production, and components of raw materials, and it will show the use of the product, the consumption, recycling or reused, and the processes of waste management. Then we move to energy production, which is concerns the possibility of recovering energy by heat or electricity. Energy consumption. This takes into account the energy consumption due to various processes. Then we have transportation. This concerns the transport, of course, used for moving product or co-product. And it basically concerns the quantity of product transported per kilometer. And then we have the waste treatment. This considers the treatment that are applied to the processing waste and also auxiliary methods. So let's move to the third phase of our life cycle, which is the life cycle impact assessment. Basically, this phase allows to determine what are the potential effects of the analyzed system on the environment by linking essentially the inventory data to specific impact categories. These impact categories are indicated here in the table. We can see ecosystem impacts, such as, for example, acid rain. We can see human impacts, for example, ozone depletion, and we can see resource depletion. For example, it can be, forest or soil. When considering life cycle impact assessment, we can refer to the following environmental issues that are shown in this slide. It is important to underline that the impacts can persist on a local, regional or global scale and concern different environmental sectors or effects on human health. Such impacts of the analyzed system can be measured through indicators, which I will be showing you below. First, primary energy. This indicator considers the primary energy, of course, demand for the entire life cycles of the considered product. For example, combustible materials therefore contribute to this indicator with their primary energy content. The characterization factor in this case is the calorific value of the material considered. Then we have the greenhouse effect. The greenhouse effect is calculated considering among the substances emitted into the air those that contribute to the global warming potential of planet Earth. The mass quantity of each substance, which is calculated over the entire life cycle of the product, is multiplied by a weight coefficient called, as I said, the global warming potential. Then, by adding the contributions of the various substances, the aggregate value of the indicator is obtained. Then we have the reduction of the ozone layer. The reduction of the stratospheric ozone layer is calculated referring to different substances and with a different weight coefficient, which is called the ozone depletion potential. Then we have acidification. This indicator is linked to the emission into the air of particular acidifying substances, for example, sulfur oxides, and the reference substance is SO2, and the weight coefficient is called the acidification potential. Then we have eutrophication. The substances that contribute to the eutrophication effect are compounds based on phosphorus or nitrogen. And the reference substance is phosphate, and the weight coefficient is called nitrification potential, NP. Then we have photochemical smog. All those volatile organic substances that lead to the photochemical formation of tropospheric ozone are grouped under the name of summer smog, and its characterization factor is called the photochemical ozone creation potential, with the reference substance ethylene. Then we have solid waste. Due to the fact that this indicator groups all solid waste that are generated in any activity in the life cycle of a product, there are no characterization factors for this indicator, and each substance is added to the others simply by taking into account the quantity emitted in mass. We have finally come to the final phase of our LCA, which is the interpretation. As I said, the interpretation is always active, as you can see here in the figure on the right. With the interpretation phase, it is possible to understand the result of the study in order to contextualize it, and also to be able to indicate an improvement of the system by identifying the components to which changes can be made in order to reduce the environmental impact of the whole system. As I said, even if the interpretation phase is linked with the final result, interpretation data is necessary at every phase of the LCA methodology. Finally, the objectives of this phase are translation and interpretation of the results, the verification of the achievement of the study objectives, data quality and system limits, but also to compare the possible options. It is important to underline that the result must be interpreted and represented in such a way as to have a perception of the results that is easily usable, also trying to represent scenarios other than the one considered.